Hello and welcome to the webinar, Continuous Load Testing in Agile Environments. My name is Goran Begic. I'm a market manager at SmartBear, and I'll be your host today. Our presenter today is Mike Punsky, Load Testing Manager at SmartBear Software. Mike's area of expertise is in software tools and services for performance testing of critical web applications. He has 18 years of professional services experience at both software and consulting companies. Before we go into the main part of the event today, we are just going to go over a couple of things to keep in mind in terms of providing feedback and connecting with us. First of all, we go to this housekeeping, which is going to take just a few minutes. Then we are going to go into the main session, and at the end we will have questions and answers session where we will try to answer all the questions collected during the session. You can submit questions at any time. You can see the questions feature in your GoToWebinar panel. You can go in and type questions there. We will reply either directly in the chat or at the end of the event in the Q&A session. On-demand version of this recording of this webinar will be available within 24 hours after the event. And we are also going to follow in a blog and try to answer all the remaining questions that are there. And at this point, I'd like to hand over the microphone to Michael.
Hi, everybody, and I'm Mike Punsky. What I'd like to do first is go over a few definitions to make sure that we're all on the same page as I go through the presentation. So the first definition that I'd like to bring up is a definition of load testing. And for our purposes here today, we're going to say that load testing is the process of putting demand on a system and seeing the results. What you want to do is you want to be able to measure the response of your system, whether that's your application or a portion of your application, and you want to see how that changes over the course of time. Load testing is performed to determine your system's behavior, and this can be under both normal and anticipated peak load conditions. And as you'll see later on, we're not always talking about a very heavy load. You can get a lot of results at lower levels. The next definition is continuous testing, and this really applies to the Agile development environment. And what we're talking about is making testing a regular part of your development process. This can be Agile or otherwise, but it's continuous testing. It's not that you just bake in a couple of points along the way and perform your testing at those points. You're testing continuously throughout the entire development process. You have your performance engineer plugged in from the beginning. The next definition is an Agile development environment. What I want to say is that for our purposes here today, because we're expanding the definition a little bit to be more inclusive, we're going to define an Agile development environment as one that employs iterative and incremental development. Performance testing and Agile work very well together. We're talking about things like iterative testing, incremental testing, and rapid and flexible response to change. These are very important characteristics of Agile, but they're also very important in load testing, and the two fit together hand in hand. When you test, when you perform load testing, you want to do it in an iterative way so that you test, you find out where you're at, you make improvements, you test again, and then you set a new benchmark. And it's a never-ending process, making sure that you don't have things that stick out as bottlenecks. You make sure that you don't go backwards on performance, and you make sure that all of your components live up to expectations as you go along. Incremental testing, we're talking about testing things at the lowest levels. Test a small function and then build on that. If all of the pieces work, then chances are they'll work good together. But you want to start out by testing them individually and finding out how each of those components work. Also, you need to be flexible and you need to rapidly respond to change. In an agile environment, things can change pretty rapidly as new requirements come in or are modified. And you'll find out that sometimes when you do that, performance can get left by the wayside. But if you're testing continuously, hopefully you'll catch that as soon as possible and be able to make the corrections that you need to. You want to be able to establish performance goals, and you want to create performance tests that go right alongside your functional tests. You want to incorporate your performance tests into your build process. So start by establishing performance goals when you write your user stories. For example, if you're creating an online store, you may say that a user should be able to add an item to his or her cart, and that process should take no more than half a second. Next, create your performance test alongside your functional test. Don't do one at the expense of the other. Instead, give them equal weight. Also, see if you can reuse functional tests as performance tests. It may be possible to incorporate timers into an automated test to give you a feel for how the application is responding. And then finally, include your performance tests in your build process so that each build goes through performance testing. By doing this, it's easier to determine what caused the slowdown in your application's performance, and if you need to roll back to an earlier build, you know how well that particular build performed. The first organizational point of Agile Scrum is the concept of a team that produces a usable version. That includes dev, QA, tech writers, and in our case, should have a performance-minded tester. And then, of course, another aspect is that the stakeholder is tightly involved all along. So unlike with Waterfall, QA and technical writers get plugged in from the very beginning. And they're there for each iteration. It's a concept that's different from test early and often because that concept still refers to Waterfall. Early means before the software is transitioned to QA. With Agile, you basically test all the time, and that's where continuous comes in. The first organizational difference is that the performance person needs to be plugged in from the very beginning, and that's a prerequisite for Agile performance testing. Second, one of the main premises of Agile is chunking things up. You don't solve a 12-man-year problem at once. You solve 12 one-man-year problems in sequence. Where the same approach can be applied to signing off the performance of the application. Layers of performance can be approached in an onion-like fashion in the rhythm of the sprints. Continuous may mean different things in different scopes. First, of course, we have continuous integration, which is a build and a small set of smoke tests run after every single check-in. Continuous testing may run on a sparser time scale, for example. These performance tests, what are the performance folks going to do? Well, functional testers are going to write functional tests to match the sprint functionality. Those tests can be at least partially converted to performance testing scenarios. This can be one of the key anchor points for the whole story. You want to leverage your functional test pieces to build a performance test. This also allows setting up work scenarios, and these can later be used as building blocks of final load tests. Data preparation is something that you need to look at closely. It's probably easier to prepare relevant data gradually as the functional scenarios become available. Smaller scope, single user performance tests are key here. These are not scaled up, but provide some metrics that are as you go along, if you test at the smallest increments and you use a small amount of load, you still get valuable information as you perform your iterations. If you're using, let's say, 5 users, and you see that your performance is half a second, if later on, after you've made some changes, the same 5 users produces a response that is double that, then you've got a problem, and you need to work on it. You can always see the delta between where you were and where you're going to be. If the success criteria for a sprint includes delivery of a working software version, performance and capacity should be a sign-off metric. If there's bootstrapping of functionality in multiple sprints, then you need to at least look at these items as challenges. The main goal of Agile was to set up an approach to more effectively manage change in both external and software functionality. Part of managing change is providing quick feedback on when change in software happens, desirable or undesirable. The significance of the continuous regression is to shorten the feedback loop. The fact of the matter is that change will happen, and it does impact maintenance of all sorts of tests along the way. There are some things that are probably very hard to do until much later in the delivery cycle. Stress and high-capacity load testing is one. The staging environment may not support that level of capacity, and you need to take that into consideration when you're performing your tests. You may need to actually perform some of these tests in your production environment. So one of the things that we're talking about here is you want to be able to test the functionality of all of your individual pieces before you perform a test against the whole. If you're performing a test at the very high end, where you're finding out how many users can use the application and how quickly they can ramp up on the system, how many errors are generated when you're at your peak, then that's something that you want to save towards till the end. As we all know, a lot of times your staging environment and your production environment differ significantly in the amount of resources that are allocated to each, and you might need to perform those tests in production. Also, if you're performing them in production, you may need to test from outside your firewall coming in from the cloud, whereas your earlier tests should be performed using software inside your firewall in order to eliminate all of the other noise that might come into play during your test. Here is a quick chart that shows how the flow normally goes with iterative load testing. And here you see that you plan your test, you execute your test, you analyze your results, you remediate anything that you find that might be a bottleneck or might be slowing you down in some way, you improve your performance, and then you plan your next test. Every time that you improve something, the next time you run your test, something else will be an issue. So you always want to keep going through. It's a never-ending process. So, to the point that we just mentioned, is your staging environment an accurate representation of production? This comes into play at the end when you're running your large load tests, and staging may not be adequate to give you the numbers that you're looking for. Not only that, it may not be able to tell you whether you'll be able to reach the numbers that you're looking for. What you want as a minimum in your staging environment is, if you can't have the same scale, then have something that is as similar as possible, although not at the same scale. So if maybe your machines have 1/3 the capacity for your database, for your web servers, for your application servers, then you might be able to say that if you can do N on your staging environment, that you can get up to 3N in production. So that's something that you can do when you're planning your staging environment and you don't have that same amount of budget to allocate. But in a lot of cases, the resources are just not there. And if you need to do your testing in production, then of course you want to save all of that testing towards the very end. You want to be able to test at a time when there are as few distractions or X factors as possible hitting your system. So do it at like 3 o'clock in the morning. If the weekends are your slow time, then you probably want to do it over the weekend as well. Defining your workload. So in the beginning, you're going to start out doing small incremental tests, and then later you would combine these into a more realistic whole. So here's an example using SmartBear Load Complete. And in this example, we have a test set up for an e-commerce site. And here you'll see that this is coming in from the cloud. And also it has two scenarios running at the same time. One is a group of users that's just browsing your site. And then the other one is a group of users that are actually purchasing something and checking out. This is a great way to have a realistic load test of your system. However, this is something that you'd want to save for the very end when you're coming in from the outside and probably hitting production. What you would look at initially is something more like this, where you have one virtual user. I know this is a little bit harder to see, but one virtual user executing one scenario, and it's running from your local workstation, so that you're able to get your numbers, you're able to tweak, you're able to tune, and you know that your component's working to its best capabilities, but not actually going out and putting a lot of mud into your test. Another question is, are you going to use real data or are you going to create dummy data? In a lot of environments out there, especially in the medical world, using live user data for your testing just isn't going to be a possibility. You don't want to run that. You don't want to give access if you're coming in from the outside. You want to be able to make some of this data up, and you want to be able to make it up in such a way that it's as realistic as possible. In other cases, you're actually going to want to use live data. So you can use live data off your system and then just set your database back to its pre-test condition when you're done. So that this is one of the reasons why you want to use data that's as realistic as possible, because your database is going to cache a lot of information based on what has been requested previously. If you run a load test and it's logging in as the same user every time, and it's filling in a form field, a set of form fields the same way every time, and doing the same inserts into a database, you're not really testing your system at all. Also, there may be some data that will not be caught or will cause an error, and you might not catch that if you're using homogenized data. So you want to try to get it as real as possible, and in some cases you can use data that's made up, but you'll want to use different data for all of your virtual users. And then there's another question about data being reused during the test. In a lot of load testing software, you have the ability to use different data for each virtual user, but you could reuse data if you don't have enough. And so I've seen this a lot, where you have a test that's going to run for a long period of time and has a large number of virtual users, but you have a limited set of data. The best scenario, of course, would be to have a very, very large set of data and not have anything ever be repeated. But depending on the test that you're running, maybe having data unique to each virtual user and then have it repeated at some point might be a possibility. Especially if you're using live data, you may not have the ability to scale it up as large as you might like. And then there's a question of who needs to be involved during the testing. So your performance person or engineer should be involved from the beginning and be an integrated part of the team. When tests are run, those results should be available to all of your team members. They should be available to your DBA, they should be available to your network person, they should be available to your developers, and everybody is going to have a different perspective on any performance problems or any errors that come up, and it's good to have it looked at from all different perspectives. A DBA is always going to see a performance problem as being related to the database. A network person might tend to think that it's bandwidth that's the problem, and your developers might think that it was the way that something was structured in the code, and that something might need to be refactored. This becomes even more important when you run your load tests at the end of the whole application, because sometimes it takes a number of different sets of eyes to provide the clarity that you need to find the actual problems. From the very beginning, when you want to run a load test, you need to determine what your criteria for success is going to be. Is that criteria that a certain functionality needs to return in half a second? Is it that a certain number of users should be able to do that function at the same time successfully? Figure out what that criteria is going to be before you run your test, and then base the success of your test upon that criteria. And as we've been saying, start small. I mean, one thing that I've seen as a very big recurring theme when I've run load tests for customers is they always overestimate the number of users that can be using their application or a portion of their application at the same time. There have been applications where a number of, let's say, 300 users doing exercise in their application would be enough to cause that application to be extremely slow and unusable. But yet, they wanted to start out with something like 3,000 to 5,000 virtual users. One thing that you can do if you're running your larger tests is look at your analytics and determine what has been done before. If it's a completely new application, then the rule of thumb should be to start small and build up from there. So run any number, you run as many moderate tests as you can, and then ramp up from there, see what your results are, and then build upon it. You can get a lot of good results at very low levels of load. So by starting small, you're going to be able to correct a lot of problems before you do your heavy testing. And this is going to ensure better results when you do your heavy testing. And I can think of a number of load tests that have fallen apart pretty quickly under load. And if some smaller tests had been done initially on various portions of the application, these bottlenecks would have been known and corrected long before the large test. If you run a large test and you haven't done this preparation, then what you can end up doing is having to repeat that large test numerous times in order to get the results you're looking for. It's much better to be prepared. As I said, start with single scenarios and then build your way up to multiple scenarios. The smaller your test, the greater your insight into where your errors and bottlenecks are coming from. Load origin is key here. There's been a lot of people bandstanding about having load come from the cloud, having load come from real browsers. But from what I can see, there is a need and a use case for all types of load testing. So for small iterative load testing, the best tool for that is to use software that you run inside your firewall. I mean, you're paying one licensing fee, or it's free, or a smaller cost, and you can run as many tests as you want for no additional charge. So what you're doing is you're running as many tests as possible, you're getting the best results possible, you're tweaking and tuning, and you're not getting any of the noise or X factors of additional users coming in from the outside, or any of the other pieces that, such as your providers and external influences. Everything is very key to your application. Once your application is tuned as well as it can be, then you're going to want to run something from outside the firewall, generally from the cloud, and you can have users coming from different cloud regions. You can scale really high, and you can find out how your application performs under real-world conditions. And then you might actually want to get to the point as well where you do some testing from real browsers so that you get very, very accurate results. How does the page appear? How is the JavaScript loading? How is the CSS looking under this load condition? All of those other pieces as well. The key here is to use the right tool for the task at hand. And a quick chart with some examples. If you're doing unit testing, application server tuning, smoke testing, bottleneck analysis, these are all good candidates for inside the firewall. Bottleneck analysis crosses the line. You can do some bottleneck analysis from outside the firewall as well. You can do your heavy load testing, stress testing, capacity testing, all from outside the firewall. And then, of course, inside the firewall, you want to be hitting your staging environment. And when you end up coming in from outside the firewall, you'll actually be hitting your production environment and all that that entails. It is important to have key personnel present when you're doing the testing and to share information back and forth. You also should be able to follow a process so that you can compare the results of your current iteration with the previous results and the results previous to that. You always want to be moving in the right direction, and it helps to have a historical perspective of how things were and to move in a better direction each time and make sure that you don't go backwards. Another thing here is parameterization. So when you're defining your test, the importance of using as much varied data as possible, you can't really overstate it. Many factors can only be properly tested if you're using actual or at least realistic data. And some examples of things that you may want to parameterize are user IDs and passwords, different search terms. So it's possible that certain search terms are going to take longer to return than others. You want to test a wide variety of those search terms. Different quantities. By testing for different quantities, you could actually uncover some bugs in the application as well. If something goes into a negative number, for example, and isn't handled the right way, you can find some of that out as well. And then form values. So anytime that you have a form that's going to be inserting data, you want to have the information on that form be as varied as possible. And then another, I would call this an art, is analyzing your generated test reports. You want to be able to look at your test reports, understand everything that's being presented, and you want to come at it from different angles. You want your business owner to be looking at your reports. You want network people, DBAs, developers. Everybody that is involved should be able to provide their own perspective. I've actually had cases whereby in the middle of a load test, we've stopped it, taken a quick look at the results, and decided, well, we need to add some more instances of Apache, or somebody needs to do something about this particular index that's not returning very quickly from the database. And customer has had the people on hand to go in and do those things, restarted the test, and gotten better results. But it's a case whereby if people aren't involved, and especially when you're doing your higher end testing, and you're looking at it the next day instead of during the test, you might take a lot longer to get to where you need to be as far as results. You want to make sure that you get all of your bottlenecks nailed down, and they can come from anywhere. So as I mentioned, either missing or non-optimal indexes can really, really slow down any application. Database locking, some of your application logic may be flawed. You may need to get some of that refactored. Non-optimal code loops, it's very easy for people to write code, for developers to write code that does things in a brute force sort of way, and the paradigm that's being used for a particular loop or section of code might not be as optimized as possible. So you want to be able to find these things and get them corrected. Another thing that is very key in your applications is caching. There's so many different layers of caching that can be involved in your application, and caching can make something, part of your application can be 100 times faster if it's cached than if it's not cached, depending on what it is and what level of caching is implemented. You can cache pages of your site. You can cache queries. You can cache your results to RAM or to disk. And then there's the question of how often are you, what's the duration that you're going to be caching for? Is this information that can be cached for a day? Is it information that can be cached for 5 minutes? There are cases where you need to have something be as current as possible, but yet if you have a 2-minute delay where it can be cached, you could actually gain a lot of performance right there. So caching is something that everybody needs to look at, and it's something that is very key to how well your application performs. Hardware is something that is always looked at as one of the first things that people want to look at when it comes time for performance. But really, a lot of times, it's not the hardware. If you get everything else working fine, your current hardware might be completely adequate for the task. And that hardware might end up being the last place that you need to look. Other times, hardware can be the problem. So you have to look at everything and balance things out to find out where your problems are. Network. If you're running a test from outside your firewall and you notice that as you add virtual users, your load is building up and you're getting more and more throughput, and then at some point that flatlines, then chances are you've got something that's limiting your amount of bandwidth. And, whether that is a piece of hardware or something to do with your provider can be looked into at that point. But definitely network is a place that you can look for your performance. And then third-party calls. These days, third-party calls and content are all over people's web pages. Whether it's social media, whether it's advertising, whether it's analytics, your own personal, your company's personal content might be 20% of your homepage. and 80% of that might be coming from other sources. Unfortunately for you, a customer coming to your website thinks of everything that's on your site as being you. So if one of your third parties is not performing well, it reflects directly on you, and those things need to be looked at as well. When you remediate these things, you're going to be adding or rebuilding your indexes. You're going to be adding or optimizing your cache. You'll be upgrading hardware, adding new hardware, optimizing network components and settings. You'll work with your third parties to optimize any of those calls. You could have an ad server that is because of the way that the ad is placed into the code on your page, it might stop other things from happening on your page and be causing that page to take a long time. So you'll need to work with your third parties to get that corrected. You're going to need to optimize code loops, refactor code. All of these things take time to remediate, so the best thing I can say is test all the time and provide your corrections as you test. So the sooner you begin your remediation, the better. And by utilizing continuous testing, there'll be fewer costly surprises at inopportune times. One thing that we see all the time now is a development group that puts together an application is sure that it will perform well under heavy load, and it just gets released, and then they find out that the amount of traffic on that site is going to totally take it down once it's up. But if you've been including performance testing continuously throughout the way, there'll be no surprises at the end. And so now it is time for questions. And remember, you can still ask questions now, and even during while we're answering questions, just type your questions into the GoToWebinar panel.
Thank you, Mike. We are just going to be mute for just a moment, and then we're going to continue with questions. All right, great. So this is Goran again. We have a number of questions we received from the registration and today during the event. So we'll try to answer as many as possible. And for those who that we don't answer, we'll follow up most likely in the blog. So if you go and check the blog on smartbear.com, you will see more information. So I'll start with a question for Sergey, who is our product director. There was actually a couple of questions about this being posted. The question is, when do you start load testing, and when do you stop performance testing? Can you maybe help us with that one?
Well, first of all, thanks for everyone who is on the line. It's actually great to have such a large audience, and there were an overwhelming number of excellent questions. So we probably should do at least one blog, as Goran said, and maybe even more, because they really cover a lot of topics. And the question that was just put to me is one of that type, because it really encompasses a lot. My short answer to this question will be never. So you would start your performance testing much like we elaborated on during the presentation, as early as you can, depending on your development cycle. And of course, there are degrees to which you can or cannot implement specific approaches or track specific metrics. But assuming that you build up your performance testing during your Agile sprints, what happens after you've put your product out, presumably reasonably tested, is actually performance monitoring. So once you've gone through all the work to establish that to the best of your ability, you can estimate the performance of the application as satisfactory, and then you deploy it. You would use the tools to monitor whether the pages continue to be performing as they were before. There are performance monitoring tools out there, including something that SmartBear offers to the market through our alert site unit. And basically, that type of performance testing will alert you to any changes to the performance that you've established, whether those would be due to unexpected traffic to the site, to glitches with hardware, or any other software configurations. So really, it's basically for the life of the application, assuming that it's performance sensitive to a degree. It can be a business requirement, it can be a user satisfaction requirement, or anything else. So really, you need to start as early as you can. You need to continue Wakehouse deployment.
Thank you, Sergey. So I'm going to switch to Mike. Mike, are you with us?
Yes, I am.
Excellent. Here's a question about stress testing and load testing in Agile environment. And so the question is, how is stress testing different from load testing in an Agile environment?
Well, stress testing is when you take your, one of the things that I want to point out is that these terms are often used interchangeably, and that different people use them in different ways. But I would say that the difference between stress and load testing is that load testing in general is to provide a certain level of load and then be able to monitor how your system responds at that level. That may not be all the way at the high end. It may be a normal level of load. Stress testing, on the other hand, is putting your system under stress. It's taking your system up to the point where it can't handle anymore, and see how your system handles being able to recover from those peak level of loads, and also see how you might, let's say failover is an option at that high level, or see how your cluster responds, or what the actual time to respond is when you're completely maxed out. So stress is the very, very high end, and load could be normal or increased levels.
Excellent, thank you.
Yes, I'd like to add something to what Mike just said. Given that these are different types of performance testing with different objectives, one is actually a lot better suited to Agile than the other. And then that's, Mike pointed out, load testing is basically some normal load and monitoring a predefined set of metrics based on the performance of the application. And this is actually perfect for the Agile approach, because with Agile approach, what you're looking for more than anything else is difference. So I got a new build today. Let me compare the results with what I had from a week ago. And whatever the differences are between the deployment environments, the versions, and so forth, with your test setup and production, are somewhat less relevant because you're tracking differences with the same baselines. However, with respect to stress testing, your hardware is a major component of the scalability of the system. And so unless you are able to put your software in production or similarly sized environment, you aren't going to be able to do meaningful stress testing. So from that perspective, there's actually quite meaningful difference between the two.
Okay. Well, thank you very much, Sergey. So now, going forward with the questions we have received, a question, what's an ideal approach to cloud-based load testing? So you mentioned testing in different environments. How does cloud-based load testing play into that, and what's the ideal approach?
That's an interesting question. Well, first of all, there's nothing ideal in this world, obviously. But to the best we can get to it, cloud testing, and we have to be careful because there are a number of load testing providers out there where you would pay for the consumption of load testing services. They frequently utilize cloud as their load generating medium, but particularly with respect to agile approaches, even if you can put your application out so that it's accessible from an external cloud via VPN or just in at a public web server, there's going to be incremental cost with respect to continuous testing. So this is something to keep in mind. So ideally, you would set up a stage testing, as Mike described before, where you would do frequent testing using on-premise software, and occasional testing, particularly if you need a high number of virtual users, as would be the case with the stress testing, from the cloud, because what cloud gives you an option to do is scale your load fairly high because of the hardware on demand availability. What other interesting options the cloud allows you to have, and let's talk about Amazon. Some of the smaller providers wouldn't necessarily offer that option. That would be geographic diversity. So if your assumed clientele will be logging to your website from different domains, then obviously not very exactly, but you can still model the distribution of traffic from different areas of the world and assess the response of your website this way. What is particularly interesting in that scenario is track your metrics with respect to every specific group. Let's say if you have load coming from Singapore and North America and Europe, then your responses, page responses, the slowest page and so forth, may be different depending on the region, and that's what you would be keen to find out through the geographically distributed testing.
Mm-hmm. Thank you for the answer. So I'll switch back to Mike. We still have a little bit of time available, and we'll try to go through your questions, which are excellent. And the question, Mike, about the capacity of the staging environment. So what should be the minimal capacity of the staging environment compared relative to the production environment to have valid, real performance and knowledge of data?
Well, I mean, it always comes down to a matter of money. So, I mean, the optimal situation would be to have an exact duplicate of your production environment, and that is so often not a real possibility. So I would say a fraction, but a similar fraction of production. What I mean by that is if in production you have a cluster of database servers being fed by a cluster of application servers, which are being fed by a cluster of web servers, then maybe you want to also have the clusters in your staging environment, but not as many. So if you have 10 front-end web server instances feeding 5 application server instances, feeding 2 database servers, or let's say 4 database servers, maybe you want to change that to being half those numbers, or even a third of those numbers. But you want the overall makeup to be as similar as possible, even if it's not exactly the same scale.
Thank you, Mike. So a question about, I mean, you mentioned the environment with different servers. The information logged on the servers, like memory usage, virtual memory, process usage, and so on, are very important to identify and monitor the load on the server. How is this typically addressed, and how is server-side monitoring integrated in test report? Can you maybe tell us more about that?
Sure. One of the things that, okay, getting some feedback. One of the things that most software is able to do right now is able to monitor your back-end processes. So if your servers can offer up some statistics or metrics, the load test software is able to incorporate those into the test. If, for example, you're also, in addition to monitoring the number of virtual users and the page response time and the time to first byte, the time to last byte, and all of those pieces along with errors, if you're also able to monitor memory consumption on your web server, memory consumption on your application server, and some CPU statistics on your database server, you might be able to start seeing a correlation between some of the problems that you observe and some of the numbers coming back from those servers. If, for example, you notice that your database CPU is spiking up to 100% and staying there for 30 seconds, then you know that there's a problem there, and you can immediately address that. If you see that you're getting very low on application server memory, or you can see that you're swapping, then there's also a problem there. So the more information about all of the pieces of the puzzle that you can pull into one common report, the better, because it enables you to find out what the actual problem is in a lot of cases, rather than guessing based on circumstantial evidences that you might see. It's sort of the equivalent of having a cough and being diagnosed just on the basis of that cough without including an x-ray of your lungs and some blood work and some other things that might go into that helps to form a much more accurate diagnosis.
Thank you, Mike. So related to that, I was skimming through the questions. Again, thank you all so much for submitting the questions. There is a question about network latency, bandwidth, throughput. How do we test the network, or how do we include that part of the system when doing load testing?
And who is that directed to?
Mike, maybe you can give us just some overview of how would we go about that, and how do we include these network latencies and other network characteristics in a load test?
Okay, well, that's one of the areas that's a little bit harder to actually test directly during your load test. It's one of the things where you can see circumstantial evidence that bandwidth might be a problem, and that's one of the reasons why when I said earlier that you should have people involved from all of the various areas such as networking, database, applications, development, etc., it's good to have people involved from all of those. And as I said, if you have a throughput problem, generally that can be traced to some network component. As you get to a certain level, you see that your bandwidth is, the amount of bandwidth you're using is increasing and increasing and increasing, and then it plateaus. So you've hit some sort of artificial limit at that point, and you might need to find out what's holding you back. It could just be a setting in one of your devices, your router or your balancer. Now, again, if you have your network group monitoring network components during a test, they might be able to see that there have been problems occurring at the same time as the test and go back and be able to diagnose those. So there aren't things, generally you can't diagnose your network problems directly, but you can see evidence that those problems do exist. And having your network people involved, they can be rendering their own monitoring in the background and run that at the same time as the test in order to get the most complete picture.
Great. Thank you, Mike. Mike Pansky, our presenter today. We are going to wrap up here, and I think we will still answer some of the questions offline. We are coming to the end of this session. Thank you, Sergey. Thank you to all of you who have stayed with us until the end of the discussion. Again, this was just one event. We want to continue discussing this topic with you. We are committed to providing solutions that will allow you to be more efficient with performance analysis early, and including the Agile environment. So please stay in touch, send us your feedback. At the end of the webinar, at the very end, you will have a short survey that you can fill in and send us more feedback. So thank you very much for the session today.